All right, let's look at the homework 4.7, problem number 6. All right, so we have to have a certain margin. So top margin and the bottom margin must be 9 centimeters, and right and left margin should be 6 centimeters. And printed material, the area is fixed at 864 square centimeters. And we want to find the smallest possible paper size, or paper or poster. All right, so let's do that. All right, so I'm going to use the width to be x, and then the height to be y. All right. Then because of the constraint here, so let's see, so area here is going to be, you have to subtract 6 and 6, so you have x minus 2 sixes, so it's going to be minus 12, right? So this is going to be x minus 12, and then this is going to be y minus 9 and 9, so it's 18. Right, so y minus 18, and this is fixed at 864. Right, so that's the condition, and then we want to minimize the area, which is going to be x times y. Right. But we would like to rewrite it in terms of just y, so it's going to be, I'm going to use this first equation, solve for y, so divide by quantity x minus 12, so you have a y minus 18 is equal to 864 over x minus 12. And then we can just add 18 to both sides. So y is equal to 864 over x minus 12 plus 18. Right? So we have this alternative expression for y. So I'm going to plug this guy right in here. So it's going to be x times that. So I'm going to put 864 in front, and then x times x minus 12, and plus 18 times x, so 18x. All right, so looks like 18 is a common factor. Maybe I'll just do it on the side. So you have 864 divided by 18. What would that be? That would be, so it's going to be, let's see, 5, 6, 4, 4. Right, 4 times 8 is 32. Right, and the 4 times 1 is 4, so it's going to be 72. Then you have a 144. It's an 8. Would it work? 8 times 8 is 64, and 8 times 1 is 8. So it's going to be, yeah, that will work. So it's actually 48. So I'm going to pull out 18. Then we would have 48 times x over x minus 12 plus x. Right, so we have that. All right, then restriction on x would be, I guess he has to be greater than 12, right? Because you have a 6 and 6. So this is going to be on greater than 6. And it could be as big as you want, so I guess we have that. All right, then we're going to have to take the derivative to find the critical number. So a prime of x is going to be equal to, right, so 18 is just a constant multiple, so I'm just going to put the 18 and forget about it. Right, then we're going to have to, let's see, there's a 48. Then we're going to take the derivative, so 48 is taken care of, and we're going to apply a quotient rule on that one, right? So we're going to have, right, square the denominator, so you have x minus 12 squared, and the derivative of the top is 1 times the bottom, so you have a x minus 12 minus, top is x, times derivative of the bottom is going to be 1. So you can actually then derivative of x is 1, so it's a plus 1. Right, so we have that. And you can see 1 doesn't really do anything, and x minus x cancel out. So you only get negative 12 on top. Right, so if we clean it up this way here, so it's 18 is still there. Right, and then we have on top, so it's going to be a negative, so negative, there's going to be 12 times 48. I'm going to write 48 as 12 times 4, right, so 12 times 4 here. And then you have x minus 12 squared plus 1, right? So if you set this guy equal to 0, right, you can see that here, in order to make this guy equal to 0, we want this denominator to be exactly the same as the numerator, so that the negative 1 plus 1 will give you 0. So this will this will get you x minus 12 squared. We want to be 12 times 12. So 12 times 12 I'm going to write as 12 squared. And a 4 I'm going to write it as a 2 squared. Right? Because this would be the same thing as the 24. So 24 squared. Right? So we can take the square root of both sides. So you have x minus 12 is going to be plus or minus square root of 24 squared would be 24. Right? Then we can just simply add 12. So x is going to be negative 24 plus 12 would be negative 12. Positive 24 plus 12 is 36. And obviously we're talking about a number bigger than 6, so we only use this one. Right? So if you look at the number line, and starting from 6, and then critical number is 36, and if you look at the sign of a prime, right? So if you type in something like a 10 or something like that, and if you put 10, so it's going to be negative 12, 10 minus 12 is negative 2, square would be 4, so this is going to be a negative quantity, right? And if you're plugging anything bigger than 36, so this is going to be less than 1, so it's going to be positive. Which tells you that the function a is decreasing on that interval and the increasing on that interval, which tells you that you're going to have a minimum right here. Right, so we know that the minimum occurs when x equals 36, and all we have to do is find the y value. So this tells you that the y value is equal to 864 divided by, right, you have a 36, so you have a formula here, 36 minus 12, so it's 24, and plus 18, right? What is 864 divided by 24? It's going to be 3. 3 times 4 is 12, so 72. So it's 144. And then we can do what? 6. 6 times 4 is 24, and 6 times 2 is 12, 144. Yep. So it's going to be 36, and you still have to add 18 to it. So it's going to be 54. Right, so y is 54. Right, so let's type it in. All right, we got the x equals 36, and the height is going to be 54. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.